me just summarize what we have learned, okay? So we learned common source. And in common source, this is the circuit, right? And I'm going to use ideal circuit, ideal current source. This is V in, this is NMOS, this is V out. And what is the out of this circuit? What is the output impedance of a common source when you look into the transistor drain? R0, right? And then what is the GM of this circuit? Just small GM, right? And then the gain is going to be negative GM R0, right? That's what we learned at the beginning. Then we came up with something called common source with degeneration. And we have a circle here. V in is on the top, and we add a RS here, and then this is V. And then we say the output impedance of this whole circuit is pretty large. It is R0 GM RS, approximately. Okay, if you don't see it, I just show you again. This came from this equation. R0 times 1 plus GM RS plus RS. Right, if you are more familiar with this equation. And then in that case, I will just call this one approximately. Okay, because I'm only taking the dominant term, R0 GM RS. Right? So I increase the RO. But unfortunately, our derivation show that the GM becomes GM divided by 1 plus GM RS. Okay, so this is like almost equal to 1 over RS. Okay, so what is the gain? Negative GM RO, which is negative RO GM. Right? It's the same as common source. I increase the impedance, but I reduce the transconductance, right? And eventually, we have this cascode. We have, again, an ideal current source. But now we put the V in at the bottom, and then we bias it. And this is V out. And then what is the R out? If I call this 1, this is 2. Is R0, G1, GM1, RO2, based on what we learned earlier, right? Just like this one. R0, the top one, right? And then you replace RS by RO2. But then we just say that the GM equals to GM2, right? So the overall gain equals to negative RO1, GM1, RO2, GM2. Which is in the order of ROGM squared. Okay, so that is the effort. I hope that you take a look, try to appreciate what happened. And that's what I want to say about this Cascode circuit. And we are done with the Cascode circuit. Okay, any questions? If not, we go to another topic, the